This is the 6.3 Exponential Functions Day 1 video. Today we talked about exponential functions and we talked about a lot of vocabulary. The focus for today was more on identifying exponential functions given a table or given an equation, and just kind of the basics of graphing and looking at what we've got here. So I asked you guys to do the vocabulary for homework after your quiz last week. So an exponential function is a nonlinear function in the form of y equals ab to the x power, where a doesn't equal 0 and b doesn't equal 1. B is going to be greater than 1. Now the first thing that we talked about is that as the x changes by a constant amount, your y is being multiplied by a constant factor. We talked about that using these table of values, which is what I'm about to talk about. Pardon me. Now, some of you were really good about seeing what that constant factor was, and then some of you needed to use those consecutive y values to look for that constant ratio, which gives you that constant factor that it's being multiplied by. So let's look at this first table as an example. So the first part of the definition here says that as x changes by a constant amount. So if you notice in this first table, these y values here are all increasing by 1 each time. So what you need to look for is you need to see if there's a constant ratio or a constant factor that each of the y values are being multiplied by. So I know that there's not a constant rate of change. I can see that it's not going up or down by the same amount as far as addition or subtraction is concerned. So I'm looking for that constant ratio. So you can write your consecutive y values as a ratio to find that value. So notice that if you take 4 and you put it over 8, 4 over 8 is a half. Then if you take 2 and you put it over 4, so 2 over 4 is also a half. And then the last one, 1 over 2, is actually a half. So that tells me that that first one has to be exponential. It's exponential because the common ratio there is a half, and that's what it's being multiplied by. 8 times a half is 4. And 4 times a half is 2. And 2 times a half is 1. So looking for that pattern, that constant ratio or that common factor that the y values are being multiplied by will tell you that you're looking at an exponential function. Now the next thing that we did was we did review what a linear table of data looks like, because you need to be able to distinguish between the two types. So remember, in a linear function, you're looking for a constant rate of change. That's that change in y over change in x. So if you look at the next one, you see once again that your x values are increasing by 1. And if I look at my y values, I notice that to get from 3 to 7, I add 4. And to get from 7 to 11, I add 4. And to get from 11 to 15, I add 4. So that tells me that the second table of data must be linear because my slope, or my change in y over my change in x, is equal to 4 over 1. So notice with exponential functions, there's a constant multiplier, something that I was multiplying by. I was multiplying by a half every time. Over here, with a linear function, I'm adding or subtracting the same number over time. So you can see that this one was exponential and this one is linear. So the next thing that we looked at today in our notes was how to evaluate a function given a value of x. So remember, evaluate just means that you are substituting a value in and solving the resulting expression, or you're doing that computation. So this was basically a calculator review. So here on this first one, they're telling you that y is equal to 3 to the x power, but then they give you the value of x as 5. So really all they're wanting you to do is evaluate 3 to the 5th power. So when you do that, 3 to the 5th power is equal to 243. So you can use your calculator to do that, or if you didn't have one, you could do 3 times 3 times 3. And you're going to do that 5 times because that's what the exponent is telling you to do. Okay? So we did 2 other examples, just reminding you how to enter those into the calculator. The key here on number 6, because it was a fraction, it was 1/4 to the 3rd power. You need to remember to put that inside parentheses. And then we reviewed how to change that decimal answer that you're going to get on your calculator back into a fraction. Don't forget, you press math, enter, enter. And that's where we got our 1/64. Okay? Thankfully, your calculator does know order of operations. So whenever you enter this one in, we entered it exactly as we saw it. 3 times 4 to the 4th. And if you do that, utilizing your calculator, you will get 768. Remember, you always evaluate your exponents first according to order of operations, and then we multiplied by 3. The next portion of our notes is where we spent a good bit of our time today, and that was looking at graphs and talking about parent functions. So I want to talk about the parent function aspect of this first. So notice here in exercises 8 and 9, they asked us to graph the function. Now we did sketch the graph on the coordinate plane, but here I've inserted a screenshot of my calculator screen so that I can talk about the graph. Remember, when we graphed on the coordinate plane, we just did a rough sketch, so it doesn't have to be exact, but you do need to make sure that your y-intercept is on there and that it is going up or down in the correct motion here. Then we compare the graphs, so we're comparing the parent function, which on this one is this top graph, and then we're comparing that to the function that they gave us here, which we're going to talk about in a second. We're going to identify our y-intercepts. That's where the graph is touching the y-axis. We're going to talk about that asymptote, and that is the line that the graph approaches but never intersects. And then we were going to talk about domain and range, which was a good review for us. Okay, so the function that they gave me here is f of x equals -2 to the x power, which actually on our graph is this bottom one. Okay, that's f of x. In order to find our parent function, remember, you want b to the x. So in this one, the one that they gave me, a is equal to -1 because that was -2. B is equal to 2. So for my parent function, which I'm going to call g of x is actually equal to 2 to the x power. So this top graph represents g of x, okay? Now we're going to just kind of compare these. So in my calculator, I entered both of those functions into y equals. The top one is my parent function, and the one in y2, that's the function that they gave me. Now, in the beginning of this, we reviewed the fact that a represents your y-intercept. So my a value is visible when I'm just looking at my function rule. As I said before, the top one, this one that they gave me, a was -1. A is the first number. It's in your function. So -2 means -1 times 2 to the x power if I was to write that all out. So I already knew that my y-intercept was going to occur at -1, which I can see clearly on my graph right here. So that's my y-intercept. It occurred at 0, -1. Now my parent function, a is, it's a little bit harder for you guys, but if there's not a number listed there, that's like 1 times 2 to the x. And as you can see, the y-intercept here is occurring at 0, 1. Okay? So we've done the first thing that it's asked me to do. We have our graph, and then I've identified my y-intercepts. Now what you should notice here is that the parent function, when it's being multiplied by a negative, it creates a reflection across the x-axis. So these are the same exact graph, they're just being reflected across x. Okay? Now we're going to talk about the asymptote. So I know that it's hard to see, but we zoomed in today in class and we saw that both of these lines are approaching the x-axis and they get really, really close to it, but they're never actually going to touch it. So therefore, the asymptote for both of these graphs is the x-axis, because that is the line that they are approaching but never going to intersect. Okay, we're talking about domain and range now. So domain. Remember, domain is all the possible x values that could be on your graph. The nice thing about exponential functions is that for the most part, because these are going to be continuous, meaning they're going to be connected by a smooth line or curve, and we are going to do these as if they are extending into space infinitely. So they go on forever. So I know that my domain for both of my graphs is going to be all real numbers. So remember, there's a lot of ways we could say that. We could use this symbol, which is that little double R. We could actually write out all real numbers. We could say that it's from negative infinity to positive infinity with an inequality. And all of those mean the same thing, and that is that this graph has all x values. It's going to extend into space into negative infinity forever. If it continues to go up or down for this one, it's going to continue to widen, which gives me an infinite value for x. Now the range is a little bit harder. So for the range, if you look at your parent function, what you should notice is, remember, range is your y values. So here, if it never intersects x, but it continues into space upward, then you know that all the y values are going to be positive numbers. So the range for my parent function would need to be y is greater than 0. That means it's all the positive values, not including 0. Now, on the other side of that, your other function, the y equals negative 2 to the x power, these go in a downward motion, which means that y has to be a negative number. So y would always be less than 0 for the given function. Now, all of the things that I went over this second part should be review. We talked about this with linear functions, and we looked at other types of functions and talked about domain and range. But I've noticed that some of you still have a lot of questions about it. So you need to make sure that you remember that domain are your possible input values. Those are your x's. Your range are your possible output values, or your y values. If it's a continuous function, meaning that it's connected like this with a smooth line or curve, you're going to have the inequalities. If they're individual dots, that's when we list our domain or range, and that's called discrete data. Okay, so we will talk some more about exponential functions tomorrow in class, but if you have any questions, please come in for tutoring. Have a great day.